Knuckles, and you're listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 83 for the week of August 4th, 2021. The related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com. What's up in the sky this week? As our week begins on Wednesday, August 4th, the moon is a thin crescent in the morning sky. The moon will be new on Sunday, August 8th at 13:49 Universal Time, when it passes 4 degrees north of the sun. The Northern Hemisphere is favored for seeing the thin lunar crescent on the morning of Saturday, August 7th, in the pre-dawn sky. With the moon so far north, the Northern Hemisphere is also favored for seeing the thin crescent moon in the western sky on Sunday, August 8th. That would be really tough. And Monday, August 9th. By next Tuesday, August 10th, the moon will be a thin crescent in the evening sky in the constellations Leo and Virgo. On the evening of Tuesday, August 10th, the moon will be very close to Venus in the evening sky. This is a good photo opportunity. The Perseid meteor shower peaks on Wednesday night, Thursday morning, August 11th and 12th. The peak of the shower is after midnight, near dawn, when the radiant in the constellation Perseus is highest in the sky. The Northern Hemisphere is favored for this one over the Southern Hemisphere. The meteors are swift, and you may see up to 60 per hour. These meteors come from periodic comet Swift-Tuttle, a comet that orbits the Sun every 133 years. It was last here in 1992, its first appearance since it was discovered. In the early 1990s, the orbit was not well known, and some of us amateur astronomers, visual comet hunters, were on the lookout for this returning comet. I had laid out a map showing the inward path of the comet for various times of the year, and would occasionally search the area that the path was in, where that the comet might be there. In September 1992, Koichi of Japan picked it up at about 11th magnitude up near the Big Dipper. The Perseid meteor shower is one of the best of the year, so get out and see it August 11th and 12th, and the nights before and after. You might be surprised at the end of your meteor watch, just before dawn, to see the constellation Orion rising in the east. It's back. Saturn reached opposition on Monday, August the 2nd. That means we are between Saturn and the Sun, and the planet is up all night, and we are at our closest point to it. Something I forgot to mention last week is a phenomenon in which for about a week around opposition, Saturn's rings shine more brightly than normal. Go out and look at it sometime in the next few days. This is caused by something known as forward scattering. The sun is peering over our shoulder, straight at Saturn, and the particles in the ring shine straight back at us. The nova in Cassiopeia continues to remain bright at about magnitude 7. Normally, after a star goes nova, it begins to dim, but not this one. Cassiopeia is now in our evening northern sky, so go out and see it. The nova and the magnitude of the stars in the area are plotted on podcast 83, map 3, Cassiopeia nova. This past year, I've encouraged you to attend local astronomy club Zoom meetings. I've done that and learned a lot about astronomy from the guest speakers. This next weekend, Friday, August 13th, and Saturday, August 14th, the ALPO convention will be virtual on Zoom and on YouTube, and you can join in and learn more about our solar system. ALPO stands for the Association of Lunar and Planetary Observers, and on both the 13th and 14th, the convention begins at 10 a.m. Pacific Time, 1 p.m. Eastern Time, and it lasts for 4 hours. There will be lectures on both days, lectures about the solar system objects. This is some good stuff. After Saturday's session, it resumes again for the awards meeting and keynote speaker at 4 p.m. Pacific Time and 7 p.m. Eastern Time. If you wish to be invited, and anyone can attend, contact Tim Robertson at cometman@cometman.net, and he will send you a link to the Zoom meeting. Once again, that's cometman@cometman.net. Contact Tim Robertson to be invited to the ALPO convention meeting. Will you be able to see the International Space Station this week, which for our purposes begins Wednesday, August 4th through Tuesday, August 10th? When you look for the space station, also look for any cargo ships leading it or trailing it. This week we have 4 zones. All you need to know is your latitude. North of 42 degrees north, you'll not see the International Space Station at all this week. From 10 degrees south through 42 degrees north, the ISS will be in your evening sky for at least one night this week. The north part of this band, Chicago, Turkey, Japan, Florida, the ISS will be in your sky for only the first few days of the week. Sudan, at 17 degrees north, will see it for the whole week in their evening sky. South of that, to minus 10 degrees, the ISS will be in your evening sky only for the second half of the week. Between 22 and 10 degrees south, the ISS will not be visible at all this week. South of 22 degrees south, the ISS will be in your morning sky for at least part of this week, and for New Zealand, it will be visible all week long in your morning sky, sometimes twice per morning. To determine where it will be in your sky, go to the website heavens-above.com and enter your location. Then click on ISS. We're building a greenhouse here, a large one. The cats say, "Thanks, Dad, the greatest litter box ever." I tried observing Comet 2021-01 Nishimura on Monday, August 2nd, but did not see it. I was using my comet hunting scope, the 18.5-inch, that is a half-meter reflector. The comet was near the stars Castor and Pollux, about 20 degrees from the sun and magnitude 9. It is extremely difficult to see a nebulous object this close to the sun. I have not heard of any visual observations of this comet. It was discovered by H. Nishimura of Japan on July 21st. He was using a camera and a 200 millimeter focal length lens. In last week's podcast, I discussed the discovery and how I had swept over the comet on July 8th while comet hunting, but I failed to see it. A new comet has been discovered, and next spring, April and May of 2022, it may be visible in our evening sky. It is called Comet C/2021-03 Pan-STARRS, and it was found near the square of Pegasus at magnitude 20, very faint. The Pan-STARRS system electronically scans the sky each night for asteroids and comets that may one day hit us. This one will not hit us or even come close, but it may put on a good show. The comet is expected to be closest to the Sun next April 20th, 2022, at a distance from the Sun of only 0.29 astronomical units, which is rather close, about as close to the Sun as the planet Mercury. At this distance from the Sun, it could get rather bright, perhaps fourth magnitude, which means it would be visible in binoculars and possibly even with the unaided eye. However, remember that comets are unpredictable when it comes to their behavior and brightness. The comet will remain in our northern hemisphere for all of this year, moving from the morning sky through opposition to the evening sky, meaning we'll have a continuous view of the comet. By early March of next year, the comet slips below the equator and will appear close to the Sun as seen from the Earth. In fact, up until that time, it will remain rather dim, visible in amateurs' telescopes perhaps as early as February. But that will not last long, as it soon disappears into the Sun's glare as it moves south. For the months of March and April 2022, the comet Pan-STARRS will remain within 20 degrees of the Sun as seen from the Earth as it moves south and north. By May 1st, it passes by the Pleiades in our evening sky, then continues to rapidly move northward. Through the month of May, it climbs higher and higher in our evening sky as it dims. So there you have it, Comet C 2021-03 Pan-STARRS coming to our skies next spring. The comets we can observe this week continue to be comets 4P Phae and 15P Finlay. Both are about magnitude 10 and are in our morning sky. These comets are plotted on podcast 82, map 4 comets. The positions, that is the right ascension and declination and distances from the Earth and Sun, can be found on podcast 82, comet positions. You can also get the positions for these and other comets from the website heavens-above.com. Click on Comets. Now for the astral class. Globular clusters. Generally, there are two types of star clusters in our sky. One is the open star cluster. They consist of 4 to several hundred stars and are about 400 to a few thousand light years away, and through a telescope you can see the individual stars. We discussed and observed open star clusters last week. This week it is globular clusters. These are spherical balls of stars, thousands of stars, or even hundreds of thousands of stars. About 125 globular clusters are in our galaxy, and if you have a large telescope, you can see globular clusters in other galaxies. It has been said that globular clusters are in a halo around the center of our galaxy, and that's typically true, but there are some exceptions. Globular clusters are old. The stars in them might be billions of years old. They can be large, up to 300 light years across, and contain up to 1 million stars. No two globular clusters are the same, and no two look the same. Through binoculars and a small telescope, globulars can look unimpressive. You see a fuzzy ball and perhaps a few stars outline the fuzzy ball. But when you get a larger telescope, perhaps a 12-inch, a 30-centimeter aperture or more, the details of the globulars become more easily visible. It was only when I got a large telescope, an 18-inch reflector in 2006, that globular clusters became impressive. Let's go out and look at a few globular clusters this week. In the past month in these podcasts, we focused on some large and bright globular clusters. This time we will look at a variety, bright ones and dim ones. These are in our evening southern sky. All of these globular clusters are plotted on podcast 83, map 4. Head out with your binoculars or telescope and give them a try. We begin with M4, near the star Antares. M4 is magnitude 6.4 and it's large, 14 arc-minutes in size. Now for a globular, it's relatively close, 6,500 light years away. Crank up the magnification as this one can be resolved all the way to the core. Our next one is much fainter, 6144. It's very close to the star Antares. Magnitude 9, and you will have some trouble resolving this one into stars. Now we head to the northwest a bit to M80. This cluster is small, about 3 arc-minutes across and magnitude 8.1. It's about 27,000 light years away, which is typical for many of the globulars in this area. M19 is our next target. Its magnitude 7.4 and measures 6 arc-minutes across. It lies only 3,000 light years from the center of our galaxy. This cluster may not appear round. Some see it as elongated north to south. From M19, we head 3.9 degrees south to M62. It's nearly the same brightness and size as M19. M62 is even closer to the galaxy's center than is M19. And you might notice that perhaps tidal forces cause the western half to be brighter than the eastern half. Next, we move over to 2 small globulars right next to each other. NGC 6522 and NGC 6528. NGC 6522 is perhaps the oldest globular cluster in our galaxy. It's 12 billion years old. It is magnitude 8.6 and only a couple of arc-minutes across. It's seen against a rich Milky Way background as you are looking almost exactly toward the center of our galaxy. Now compare that to NGC 6528, which is a magnitude fainter, but is seen against a dark background, probably dark nebula. So 6528, even though it's fainter, might stand out more than 6522. Finally, we jump over to 2 more globular clusters. The first is M28. Its magnitude 7.8 and 5 arc-minutes in size. It sits 20,000 light years away, and it shows some of the outlying stars, but the core is not easily resolvable. It's only a short distance to our final object, M22. M22 is one of the finest globular clusters in the sky. It is magnitude 5.4 and can be seen with the unaided eye. It's 17 arc-minutes in size. So go out there and look at these globulars. Next week, I will discuss nebula. To recap the podcast, what's up this coming week? The moon is new on August 8th. And will be next to Venus in the evening sky on Tuesday, August 10th. See Saturn this week. The rings are brighter than normal due to forward scattering. See the 2 comets in the morning sky. The Perseid meteor shower peaks on Wednesday night, Thursday morning, August 11th and 12th. We still have that nova in Cassiopeia, and go out and look at some globular clusters. You have been listening to Looking Up with Don, podcast episode number 83 for August 4th, 2021. I'm Don Machholz. Once again, the related website for this podcast is donmacholz.com. That is spelled DONMACHHOLZ.com. 2 H's. You can contact me at dontheastronomer@gmail.com. Once again, that is dontheastronomer@gmail.com. God willing and Pod willing, I'll be back next week for another episode of Looking Up with Don. We will discuss what's up in the sky. We will continue to watch those comets in the morning sky. And I'll discuss nebula. We'll go out and look at a few. All that and more. Thank you for listening. See the sky this week. I'll see you next week.